So, Dave, I'll let you take it away now and tell us about the changing world of climate change in New Mexico.
All right. Well, thanks for that great introduction, Jan. I appreciate that. And I really enjoyed the last time I was in Taos and stayed at your house. And there was a great group of folks. And I enjoyed the day and a half or so that I was there. So I'm going to share my screen and we'll talk about what's going on with our climate and like Jan mentioned, I'll conclude by talking about the COCORAS program. So I wanted to open up with a great picture here from this was actually a few years ago. I was out. Sometimes I drive on Interstate 25 to go to meetings, and I really enjoy driving during the monsoon. And sometimes I'll intentionally leave in the evening so I can stop along the way and take some pictures of the lightning. It's one of my favorite things to do. Didn't have much chance to do that this year, not only eh, um, because of COVID-19, canceling almost all of my meetings, which I was fine with too. But there was not a lot of monsoon to really provide any thunderstorms and especially lightning. So it was sort of a missed opportunity in many ways this year. I just want to acknowledge my collaborators who provide a lot of funding for me from the University of Arizona, money coming from NOAA through the climate assessment for the Southwest program, who pays for a lot of my grad students and some of my travel. So let's get started here. So there's no doubt that we're warming. So this is a map of New Mexico, and each of those black lines are climate divisions. So you may ask, so what is a climate division? So what we try to do is get areas that are similar in climate, and then try to highlight those in the areas. So we've got 8 different climate divisions in New Mexico, and and I summarized the trends of summer temperatures over each of the 8 climate divisions. And so those numbers that are in each of those polygons on the map there, those are temperature trends per decade. So if you look at the northern mountains, it's positive 0.5 degrees Fahrenheit trend. That's the temperature trend per decade. So temperatures are rising at a half a degree Fahrenheit every 10 years. And that's since 1970. And so as you can do the math, and it's pretty constant in terms of the trend. It's pretty much. I mean, there's year to year variations, but that's sort of the trends going up. So we're on target to get even warmer temperatures over in the next few years, and we'll talk about that. So over in the northern mountains, climate division is a half a degree. Just to your east in the northeast part of New Mexico, it's 0.7 degree Fahrenheit. And then even more than that is the southeast part of New Mexico, 0.8 degrees Fahrenheit trend per decade. So we're warming. It's a constant warming. We get some years are a little cooler, some years are very warm. And that 2019 was a little cooler, but then 2020 is, which is not done yet, but we're on target to be even warmer. And we've had last month, August, we actually were the warmest on record. The month of August in 2020, if you compare that month to all the months in the past, it was the warmest on record. And if you can go back even July, August, it was like the second warmest. And I mean, this has been a very warm year as well as very dry in a lot of places. So here's our annual average temperatures for the climate division 2. That's the northern mountains. That's that area that I showed, and that with a 0.5 degree trend per decade. As you can see, let me turn my little highlighter on here. So here's 2019. You may say, wow, it was cool, but you have to look at the trend. So here's starting in the 70s, there's that climbing, here's that 0.5 degree trend per decade here. So here's 1817 was the warmest on record, going all the way back to 1895. And so the mean average temperature is 46.1. And we were, even last year, it was above average, even though it was cooler than the previous few years. And so we're seeing this trend. So what we're going to be talking about, what are the implications? And that's our most definite thing that's going on, is the temperatures are rising. There's not a lot of trend in as a whole for precipitation. We've gone through some cycles with the precipitation that we can always talk about that after. But the most striking thing with climate change is the warming temperatures all over the place. I do work in South America, and they're seeing the same kind of trends, and they're melting glaciers in the Andes Mountains. And so, I mean, it's all over the place. And I was in China last year, and they're seeing the same kind of trends, and even drying in some areas. So it's not just the US or a backyard, but it's global, all over the place. So what are some of the observations of change that we're seeing? So these are some of the observations. What are people seeing if you were to look at the data? So the first one are the temperatures of the last decade were warmest of the century. Pretty obvious. You look at those graphs. If you look at the last decades and compare them all the way back to 1900, we're just climbing up. And one of the things that we're looking at is and a lot of the contribution is from the morning lows. They're not getting as cold as they used to. We're not seeing a lot of those cold records. The morning lows have been getting warmer and warmer. A lot of our weather stations are in urban areas, which is fine, but they're seeing this little heat island, but we're still seeing that trend on top of the urban heat island. So there's multiple things going on. If you live in an urban area, you're not only getting the global trend, but also an urban heating trend, which is on top of things, which is even more disturbing if you think about it. We're also seeing in most areas, we're seeing a longer growing season. So that's the time between the first thaw and the first freeze. We're seeing that growing. Some years it goes up and down, but over on the trend, it's growing. So some of the implications are that we're seeing more pollen generated because it's longer growing season, more allergens. Another thing that we're tracking is we're looking at the freezing level. You have to go a little higher in elevation in order to get freezing on average. And I was just looking at some papers written in Asia, and they were also seeing the same thing in the Himalayan mountains, and some of the mountain ranges in South America are also seeing those kind of trends. So it's something, it's global in nature. And then one thing that it's not unique to New Mexico, but we get to see on a regular basis is when we get drought years and very drying times and hot temperatures, we see dust storms is another issue that some states don't have a lot of, but in New Mexico, that's one of the natural parts of living in a semi-arid region. Even though if you're in the northern part, you're not immune from dust storms when it's very dry, and those had the potential for carrying pathogens and things. We're seeing those in the more warm areas. Things like valley fever are popped up and are being tracked by the Department of Health, as well as some of the global organizations for health. So it's one of the things. Will we see more of that as the temperatures start to rise and the endemic areas of these pathogens start to migrate north? And we're already seeing those for some of the pathogens, and we'll talk about a little bit about that in the health part. So here's some of the other expanding out and looking at. I got this collaboration with my friend Jonathan Overpeck, who's used to be in Arizona, but he's in Michigan right now. Just looking at some of the things. The biggest thing is the warming. It's a sure bet, and it's already happening. The heat waves are on track to be hotter than they used to be. For instance, like the 50s drought. It may have been drier, but the temperatures now are much higher than they were in the 50s drought, or even the 30s drought when we had the Dust Bowl. So it's a different type of heat wave and drought. We're also seeing less snow in many areas with the Rio Grande and the Colorado River and other watersheds. One of our grad students just defended his thesis last week, looking at the upper Rio Grande headwaters, and looking at what are the basically applying the climate change scenarios with a snowmelt model, and seeing that it's not only there's less snowpack, but also it's going to melt out a lot earlier, which has a lot of implications in terms of the hydrology of the entire um, watershed all the way down to Texas and Mexico. We're already seeing drier soils. It's excellent odds for happening in the future. Like I mentioned, there's less late winters and more of rain instead of snow. It's all the good odds for it continuing to happen, and we're already seeing that. Less water in rivers. I'll show you some examples. If you go to the Rio Grande right now, you can see that for your own eyes. And more frequent and severe drought. Severe meaning that they may be the most definite thing is the warming. The droughts are hotter than they used to be, and even though we may got the same um, precipitation deficit, meaning that it's going to be, we're missing so much rain, it's going to be worse because of the high temperatures. And so that kind of feeds into the hotter droughts. That's it's already happening, and it's excellent odds for that to continue with our best climate change scenarios that we're doing. And a lot of people are publishing in these areas. It's amazing how much work is being done in not only the Rio Grande, but the Colorado, and then over in the rest of the country, as well as the other watersheds across the world, seeing the very much the same kind of responses to the atmosphere and terrestrial Earth systems. So I just want to give you a few examples. This was a high altitude lake in the Navajo tribe in New Mexico, right on the Arizona-New Mexico border, and it's sort of a sign. There's not like it's mainly fed by snowmelt and rainwater, and it's about an hour and a half drive to get here, but it's a really useful small little watershed that you can see how big the water is depending on how much snowmelt it got, how much snowmelt it gets. And it's also a source of water for wild animals. Half the time I go there, there's a pack of wild horses are there sharing it with some mule deer, or maybe elk. And so this is sort of a regional use. With climate change and water resources, like I mentioned, we're likely going to see declines in the snowpack and less water available for not only the wildland, but also agricultural users. More rain than snow during the winter, and we're seeing these earlier snow melt, not only because of the less snow, and one of the reasons why is the storm tracks are changing. So it's an atmospheric dynamics change. It's a process change going on. That's not just New Mexico, but it's the entire hemisphere. Because we get a lot of our storm tracks has roots in the tropics. So, and there's wave patterns that go along in the entire Earth. And then if we start to change the temperature differential, meaning the difference between the hot tropics and the Arctic, that's gonna start to change the exchange of energy between the hemisphere and the equator, and that's kind of one of the things that we're looking at, and even on a seasonal basis that has some implications. There was some discussion at the National Weather Service about the semi-permanent high that's sitting over the western U.S., causing our droughts to be more intense, specifically this year. Is sort of one of the causes for why we had a really bad monsoon. Is this Four Corners high is even becoming stronger, and storms have to go around these highs, and nothing goes through these highs. They're really strong, and so it's in some ways it's one of our reasons why we're getting dryness, and that's one of the clues we see from the climate predictions is that kind of response to the warming of the oceans, has a response into changing things like the semi-permanent highs and lows that we're seeing. Some of them are on the East Coast. These semi-permanent highs and lows, they're the ones who steer the hurricanes. They make them come across from the east, from Africa. They go up and then they hit Bermuda High, and they make a nice right-hand turn, either before they hit land, or as they go into the Gulf. So those are the strong indicators that we see, with how climate, it actually can move those really large scale patterns. And going back to the water resources, and we're seeing that is changing the soil moisture. So and that the feedback there is sort of the dry begets more dry. There's less water vapor release from the trees as well as the soils on a large scale. So there's less water vapor overall in the system. And especially if there's not a lot of movement of storms to make more water vapor. So that's another issue with having a drying atmosphere and a drying system. So I just want to show this is the snow water equivalent for statewide New Mexico. So this is I got this from the USDA Natural Resource and Conservation Service, NRCS, and they publish these real-time maps. So this is a summary of the last water year. So it's the 2019-2020 snow. And so the black line in the middle here, this one here, that's what we did. That's our snow water equivalent. So that's the amount of snow water statewide in New Mexico. And the green line, nice smooth line, that's our long-term median. And it's a median from the 1981 to 2010. So as you can see, by just eyeballing, we were doing okay early on. We were above the median in the late fall and early winter, but right around in February, things started to turn off. The storm tracks didn't go over most of New Mexico, and we peaked early, and we peaked below the median, and then we started to melt out. We melt out early, so there's a gap between the green and the black lines, and so that shows that we had an early melt out. And it's not the worst years. We had some of our worst years were down here, 2018 and 2006. But in comparison, here's the best year. But one issue we had is it wasn't that we didn't get enough storms, because it was we were not that far off from the peak median, but our temperatures were so high. So that's this is sort of a good test to look at how climate change, the temperatures are impacting our water system. Because you can see I'll show you some graphs right in a minute that show the near record to actually some areas record low stream flow in some of our major rivers in New Mexico. Even the areas that are managed through Bureau of Reclamation moving water from one reservoir to the other, even with that, it still we're record low. And it was not from the lack of precipitation, because we had look at those years 18 and 6, very, very low. It was mainly because of the temperatures. So just as I promised, here's the stream flow this year. This is post runoff. So on the left side of each graph, the time's the same. So they start in early May, actually late April is when those graphs starts on the x-axis here, and they go all the way through the end of August to early September. The little orange or yellow, depending on your screen, those are the long-term daily medians. And like, for instance, the Animas River at Farmington, that's 96 years of data to come up with this little yellow triangles. And then the blue line is actually what we measured this year. So in the Animas, we start off right around average, but our temperatures were above average, so we melted out early. And then we were way below the stream flow. We got a few precipitation events, but we're down to almost nothing. And Animas River, we're down to just above 10 cubic feet per second. We're on average, we're usually in 300 cubic feet per second. So if we go down to the Pecos, similar thing in terms of we actually had a little bit above average, the peak, because it was very warm. So we had a lot of melt out very quick. And yeah, it really melted out fast. I mean, it was within a month, we pretty much melted out the entire snowpack in that area. We had a little bit, and this is right above Santa Rosa Lake. And so we were down to single digit cubic feet per second, where they're usually over 100. And these spikes, those are all precipitation events. So if you get a rainfall, you're going to get a pulse of rain, pulse of water down, but they only last a few hours to maybe a day or so. So we're down there in the 1 cubic feet per second. And this time of year, we should be right around 60, 70. Upper right, you're probably familiar with these, Rio Grande at the Embudo station. So here's our melt out, right? We melted out early. And we've been going down since then, and we're just down to like 100, just over 100. It's a little further down than now, but we usually are at 300 CFS, and then go further downstream on the Rio Grande and Albuquerque, the Albuquerque Bridge there. Same thing. I mean, this is fairly managed at this point, so you have the different Heron, Elvado, Cochiti, Abiquiu reservoirs. They're in we manage those through the Rio Grande Compact, but still it's well below average in terms of the amount of stream flow all the way through the entire runoff season. And so some of the things kind of summarize those, because of the higher temperatures, and especially this year, there's a thing we call evapotranspiration. So evaporation is just a release of water from surfaces, but there's the plants actually transpire. So they release water vapor through the stomatal holes in leaves and through other places, and they'll lose water. So it's the sum of the transpiration of the plants and then evaporation. And so because of the high temperatures, those really spiked up very high, and it's been amazing. I've been doing some irrigation, water conservation projects with the pecan industry, and we're out kind of like out of the ballpark in terms of the temperatures and the evaporation that we've seen. And we actually were out of the models. We had models that were based off of several years of data, and because of the high temperatures, we had to extrapolate in terms of figuring out how much water plants need. Their need is much more than we've seen in the past few years. So which means there's a lot more water requirements on plants this year. And some people have been telling me this was sort of that especially down here in Las Cruces, this was sort of, it feels like Tucson. And I said, well, that's kind of what we're heading toward in terms of down the road, if we do things the way we're doing now, our climate is going to be similar to the Tucson area. And we're already seeing that. So this is sort of a harbinger of the future. This is what our summer is going to be like. Next bullet there is seeing, because of the stress on plants, we in a lot of areas, we're seeing a lack of forage. And during these hotter and drier periods. And if we do get some forage, and it could be the quality is very poor. And I've been talking to a lot of ranchers in especially the east side of the state, and they've been verifying that for me, that there are some plants have been coming up, but it's not edible to the cattle, like there's like in the back of the slide. So it may look good from satellite. You say, oh yeah, it's all green, but it's the stuff that's coming up are the invasive species that it's in inedible crops that are you can't use. So they are one of the issues is, so it's not only climate, but the ecosystem responses, so there's multiple issues going on that are competing, and having to deal with, the ranching communities are struggling right now. And in addition to with lack of precipitation, there's adding the cost of hauling water and supplemental feeding if there's no forage out there. So those are some issues. This picture here is pretty good. We came off of a decent winter, but it really dried out. Basically, what was in this picture was there was some forage, but there wasn't much after that. So they'd have to move their animals to a different area. And that's kind of the resilience and the adaptation is if you have ability to move your animals, you'll do okay. But if you don't, you're really sunk, and you may have to sell your herd off. And we're seeing some of that. So they're culling animals and things. And more higher water requirements during heat waves. I've worked some with some of the cattle folks, and looking at the amount of water that one steer needs, and do we have that water? And then what are the consequences of having them on a deficit? So they're basically thirsty all the time, and they're basically coming up with a not so healthy animals, so they can't sell them as for high amounts. So there's issues with the lifestyle of ranching when things are going. But that's sort of if we're seeing it now, climate change is likely going to increase that in the future. So it's one of those things we have to look at. Say, okay, if you're struggling now, it's going to get worse. You may have some good years while it's going up, but in general, the next one may be even worse than the previous drought. So where are we now? I just want to show you a snapshot. This map is updated every week. This is last week's. The next one comes out tomorrow morning. So this is the U.S. Drought Monitor. It ranks drought in terms of a D level, D1 through D4. D0 is the yellow. That's sort of the pre-drought, and it starts in the light brown to all the way to the dark brown. So large parts of New Mexico are pretty much 99% of New Mexico is in this D1 to D3 category. The red is the worst in New Mexico right now. Although there's some areas like in the Great Basin over on the Utah-Nevada border, there's some D4, pretty bad conditions. And this is sort of one of those, if I was to show you a map of the future, likely we'll see more of these kind of maps, the same coloring in other areas. And I can't predict what's going to happen in 2050, but it's more like these kind of maps like this. There's more, the probability is going to go up for more of these drought, especially in the middle of the summer. We should be enjoying lots of thunderstorms this time of year, but we haven't got them. So this is sort of this area of New Mexico through Arizona, and we should be in this. Some areas get 50% of their precipitation during the summer time period, and we didn't get it. In some areas, even less than 20% of it. And so what does that mean? And I brought this up because it's sort of another clue of the future when we're dealing with a changing climate, and not only because of the lack of precipitation, the storm tracks changing, because of the semi-permanent highs becoming even stronger, but also the temperatures. And so this is a map that shows you the seasonal drought outlook. So it's valid all the way through the end of the calendar year 2020. And the chocolate colors are basically, if there's drought there now, it's gonna remain there all year. And the areas that are yellow, if you're not seeing drought now, we'll be seeing drought in the future. So it's pretty much it's like a quarter of the country, a little more than that, is in that drought developing. And even what's even disturbing is the areas in Southern California, and the areas in the Sierra it's burning right at this moment, and they're continuing to get drought even in the cold season, which that's their wet season. And so it doesn't bode well. And that's sort of the fingerprint of climate change, is sort of making things worse. If it's already seeing some of those indicators of drying and lots of fires, you may get some really wet years to provide fuel, which is sort of that feedback. You get some good years, but then a dry, and it's a cycle. Getting those wild and very intense wildfires. We're getting Santa Ana winds blowing, making 50, 60 mile an hour winds coming off of the Mojave. So that's what goes on over there. Here our development of the monsoon it has some threats through climate change, and we're seeing this already in action this year. So I just want to talk a little bit more and some of the other impacts of climate change on health. So this is mainly through the human health. So heat waves are the biggest one. I've worked a little bit this past couple years with the Department of Health, and giving them numbers to put into on a county basis to look at. So what are how many days of 100 or 95 do we have now? And then looking at the climate models, are saying, okay, in the next 10, 20, 30 years, how are we seeing those numbers of, say, 105 or 100-degree days increasing? And because they have some statistics to look at, when they get a lot of days when they're above 100, they get people going to the ER with heat stress, heat stroke, various other ailments that are just make heat actually multiplies some of these. So that's a big concern, even if it's not very hot. Even like in northern New Mexico, you don't get high temperatures, but we're more sensitive to some of the the these. You may get like a 95 or 100-degree one day, and that has a lot more implication than a 100-degree day in, say, El Paso or Tucson. That's a regular time. So we're not used to those. We're not very resilient to those. A lot of I used to live in Santa Fe. I didn't own a air conditioner, whereas it would be very difficult to live in down here where I am without an air conditioner. There are people who don't, and some of those are in the high risk categories. So it's that, at what point do you need it? When you're dealing with health issues, and so that's why we're looking at the heat waves. It's probably one of our biggest issues that we're dealing with in the changing climate. The other ones are respiratory. Talking about allergens, the time between the freezes are getting longer, and bringing a more allergy season, and even moving the endemic species from other areas into our areas, and we're not used to some of these um, pollens in the atmosphere, and so there's issues with that. And I've in the past I've talked to allergists, and they agree with that. And some of them who do take pollen counts, they're seeing these. We're still seeing pollen that we normally wouldn't see, but they're seeing it. Maybe 2 weeks, 3 weeks later in the season. And we all know the issues with wildfires. I don't think any part of New Mexico or even the Southwest has been out of smoke, or at least they've been more than one day or weeks with fire issues. If I look out the window right now, there's smoke in the air, there's haze. I'm sure there's even more in some areas of the mountains. So with the wildfires, the story is, with higher temperatures, likely going to see more of the large fires coming up in the future. And then the issues with climate change and health is that the fires are not just there where they happen. The smoke is transported in long distances. Like, I was just doing some calculations, and some of the smoke that's hitting where I live, they have traveled more than 5,000 kilometers from where the fire was, and it make this 5,000 kilometer trip across the country. And it's taking almost a week to make that trip. But so it's that, what happens there impacts the entire globe, actually. Because I was looking at some articles and some reports, in people in Norway were seeing the smoke from the California fires. They were seeing the evidence of the haze, and the sun looks a little different, and they were doing some model runs and say, yep, that's California fires. And there's issues with drought. Of course, we'll talk more about that. So, let me talk a little bit more about wildfires. And this is just show you a nice picture from a fire from a few years ago, just out on the east side of the Manzano Range. High winds, warming temperatures, sufficient fuels, and water stress, and heat stress vegetation. We just had our state drought work group meeting yesterday morning, and we had the Energy, Minerals, Natural Resource Forestry Division gave a report, and they did surveys in New Mexico this year, and they were noting a lot of big areas of the pines where they were seeing this heat stress in the pines, because they could see the changes in the needles, the coloring. And so we're seeing this already in areas, and likely going to be seeing more of those, and as well as the pests and pathogens that are out there that we have to constantly do surveys and track and look at. And when vegetation is stressed with these, they're more prone to mortality, and then you've got a lot more fuels than just the forage that's growing on the ground. And then in addition to, if we don't get a lot of moisture, we may have storm development, and so there's an increased chances of dry lightning. And so you get lightning but no benefit of the rain. So that's another threat that we're looking at. So there's a connection between the hydrology and the wildfire health issues, and it's dealing with warmer and drier springs and drier summer. Remember, there's early snow melt, lower summer fuel moisture, longer fire seasons. I was talking to one of my friends at the National Weather Service, who's an incident meteorologist, and he's currently deployed in a fire um, in the Coast Range in California, and he's been deployed like, I don't know, 3 or 4 times this year. And he was deployed in the northern New Mexico, and he's been noticing that this is a extremely long fire season, not only for the West but for New Mexico even. And so we're seeing these expand out, and pretty much all year round there's fires. As soon as and we usually get the monsoon to kind of provide the moisture, but we didn't get the monsoonal moisture in a lot of areas, so it's going to continue on. The temperatures, we're still above average, and then we get into the cooler fall and winter, we can get grass fires in a lot of areas, even though we get a little bit more moisture in the higher mountains. And so that increases our fire frequency as well as the intensity and severity. So this is a published compilation of research, and this is part of the National Climate Assessment. I encourage you, if you're really interested, it's science2017.globalchange.gov. And that's a really good resource to look at all the different sectors and how climate change is going to impact all the different areas of the U.S. And there's a Southwest section in there. I encourage you to read that. It's really well written. A lot of my colleagues are the authors of those. And one of the sections is wildfire. And they were seeing that they pretty much almost all of the regions that are in the West have seen a trending up from the 80s to the late, right around 2010 or 11. And so, pay attention to this bottom right part here. Here's Arizona, New Mexico mountains, seeing this pretty significant trend. And these are a number of large wildfires increasing over time. You can get some really low, but then you can get some really high. So there's that trend has been going up, and the only place that's been there's flat is the Basin and Range, and then there's some decrease in the Mediterranean, California. Although this is probably going to change. There's probably going to be a big spike this year in that. So it's a trend all over the West. And I just wanted to show you this. I put this together. I was looking at all the big fires, and I didn't update this for a couple years, but this is from the 80s to 2016. Fires that are more than 50,000 acres in New Mexico. And then what year did they occur? And you can see, there's nothing, I don't see anything that was in the 1990s in here. It's all been 2000s through, starting in, say, 2002 all the way to so that was the Ponio complex fire. And then the big ones have been the Silver in 2013 and the Whitewater Baldy in 2012. I'll probably update this this bar graph, but basically it's showing you not only that the last few decades were the warmest, but in response to the largest fires have occurred during those times as well. And not only just large, but by a factor of 2. So these were like the Whitewater Baldy that's nearing 300,000 acres. And some of these other ones in the middle 2000s were only in the maybe 75,000 acre, but big fires. And so what were the conditions? So I made this looking at the U.S. drought monitor using those colors that from D1 to 4. And then I noted down some of the noteworthy large fires. And probably one you probably remember is the Las Conchas fire. And I made a arrow there right here, and you can see what the drought. And this is over the drought monitor over the entire New Mexico, and as you can see, almost half of the state was in that worst category, and nearly 3/4 were in that D3, which is really bad. So that whole several year period where we got Las Conchas, Whitewater Baldy, Little Bear, Silver was pretty extraordinary, I think, and much more than the other years. And this is a 20-year period looking at. So we've had some periods here where drought has come, but not a lot of big fires. But this one was particularly a kind of the worst storm. One after another, sometimes two a year, and a lot of these are some of these droughts were from La Nina episodes. And La Nina in the Southwest, in particular New Mexico, usually results in a warmer than average winter and then a drier than average winter. And some of the other things goes on, as we all know, it impacts our water quality from debris flow. And here's a picture from my colleague Kerry over at the Albuquerque office, and he was out taking some movies at one of these wildfire events, the debris flow through the apple orchard. And we also get, as we know, the air quality as well as ecosystem impacts fisheries. We get we could get agricultural losses, as well as damaged infrastructure and total loss in some things, and as well as the loss to tourism when really things go really south, like no flow or very low flow on the Rio Grande, or snow season kind of tanks or closes, a month early. So those are some of the issues, or with wildfires, decimating an entire side of the mountain. And so I just took this, grabbed this off of the NASA website, looking at smoke just recently on the 14th. All that red and yellow, that's all smoke. So not only you can see wrapping around in a clockwise manner. So this is that big high, that semi-permanent high I was talking about, very strong. It's basically wrapping in a clockwise motion. And some of the smoke was getting wrapped up in this low pressure out here on the Pacific. So going almost, not quite to Hawaii, but it was pushing the smoke quite a ways out, almost to the Aleutian Islands. And then as they migrated through, they were impacting the East Coast, the Mid-Atlantic, and then going all the way out to Maritime Province, and then of course crossing the Atlantic. And they were actually tracking some of the smoke that is actually being entrained into the Arctic jet stream. And it was actually making its round around the Arctic, and they were checking to see if they can go all the way around the entire globe, as one of the fascinating things, but it's bad news. I just want to kind of just bring some of this, as we don't really equate climate change with air quality, but it's the same thing happening. Some of the things that impact our health now are, some of them are going to be the same, or some of them are going to get worse. Particularly like ozone. Ozone is formed in the atmosphere. This is tropospheric ozone near the ground, not the stratosphere, the one that keeps us from the UV, but the stuff that we breathe in. Seeing that we're actually seeing just recently that some of the ozone is starting to increase, and we've gotten some really good decreases in ozone because of cars now have emission controls, are more efficient. They make them with electronic ignition, so they're very, very well tuned compared to a car in the 80s and 70s, 60s. But even with that, there's more cars, and we're generating the same pollutants. And then we're also getting an infusion of air from other continents. Remember that smoke, whenever I talked about that, you're getting air from Asia, it's coming here, and then our air gets shot over to Europe. So everybody's downwind of somebody. And so that the entire Earth is actually changing the chemistry as well. So remember this, we're talking about air quality, but it's also applicable to climate change. Remember, that's the whole issue with climate change, is we're changing the composition of the air, the abundances of some of the trace gases in there, and ozone is one of those. And so we're actually bringing up the average ozone for the entire globe because of what we're doing. And so that's actually changing our health in some ways, as well as particulate matter, all these things that go on, like these fires, dust storms, then the cars, and then we've got secondary production and things like carbon monoxide and air toxics. We've talked about pollens, those are likely local things, but it's that those are all part of the respiratory things that we have to be careful of. And then also those are all in the outdoor, but we also have to consider things that go on in the indoor. So who is at higher risk over here in this yellow line? The heart, lung disease, folks that have COPD, emphysema, asthma, older adults and children are the ones who we need to, who are particularly sensitive to these trace gases and particulates that we need to be, paying attention to and protecting, because we have a choice. It's something that we can limit these, but we need to be able to do that through programs that make sense. So here's a PM 2.5. That's the fine particulate matter, and there's actually a monitor in Taos, and it's and these are this is a graph of the last, I think, 15 or so years. And it goes all the way up to September 2020. And the green is actually good days. So it goes from January through December on the horizontal in years. And so each day is a bar, and most of these are, it's all the same. So there's no, you can't see the bars, but during the wintertime, that's when we get the moderate air quality index in Taos. And likely, that's my guess. I haven't done a study in this, but it's likely maybe wood smoke, as well as that the atmosphere is more stable. So you have whatever is generated at the surface will stay there. Kind of not like Las Vegas, but more of the, if you have dust in some of these roads, they're going to stay in that area and it's not going to be transported. So um, whereas if you go in the spring, you got a lot of more winds to kind of ventilate, blow the stuff out. Whereas in the wintertime, it's more stagnant. You can get some winds from storms, but overall, in general, and that's my guess is why we're seeing more moderate days, and they've been popping up in the last 3 years. It's not, it's pretty regular. I mean, these are fires likely, these June and July ones, but these are likely stuff that's generated in Taos from Taos activities, whereas these may be transported smoke from outside the area. Back in 2011, we had a lot of fires back then too. So it's pretty good. If you were to look at the same map for even El Paso, just south of me, it's all there's, you could see the entire span of the colors. So you're dealing, your air is really good in Taos compared, but we have to be concerned with those yellow areas that not, we don't want to see an increase of those. Um, Whereas in El Paso, the whole area is lit up with green and orange, red, and purple even in an area like down here, but in Taos, it's pretty good. And remember, we're all part of this as a globe. So we have the same issues, and the greatest right now is the greatest environmental risk to health is air pollution right now. It's causing 7 million deaths per year just from the air that we breathe. And so 9 out of 10 people in the world breathe polluted air. In many places, they're above the health standards. Um, and a lot of the areas that they have intense burning of coal to produce electricity. We're sort of getting rid of that over time because of the scaling and the costs of generating electricity. No longer is coal the cheapest way. There's cheaper ways of generating electricity, and that's why we're getting rid of coal in the U.S. And so we're cleaning up our air because of that. But other places aren't. They're actually in some places of the world, they're actually building coal-fired power plants, brand new ones, and so that's not a good thing. And also, the contributing to the health risk of 7 million people dying is biomass burning, as well as the urban air. The vehicles, they don't have the same pollution controls as the U.S. does, and so it's a burden that we are paying for our convenience in here. But we there's need to be thinking about that. And but we are more resilient, and this is kind of obvious, but I wanted to show you this. We have come a long way in our resilience. So this is something I've been looking at, especially now with COVID-19, is looking at the past. So how have things evolved in the past, epidemics, and so this is an example of Mexico. So actually, Mexico was actually very populated. This is the area, they had over 20 million people before people came in. This was back in 1500s, and then they brought smallpox. 8 million people died just in a few years from smallpox. And then in addition, there was another one. Because of drought, rodents played a significant role in killing another 12 to 15 million. And then in another one, again, with the hantavirus, similar to hantavirus, 2 more million people. So it went from 21 million people down to 2 million because of things. They weren't resilient to things. They didn't know about how to treat these things. So this is one of the population class. We come a long way to know what's going on, to protect ourselves from this, but we still have a ways to go. We all know about, if you look at the news. So how do we adapt to climate change? So we look at the past, and I grabbed this image from the Egyptians, and just to see they dealt with things. If you read the Bible, they've had famines, and some of the recorded literature, and looking at how they stored grains, and they had to cope with variability in the weather for thousands of years. And so how do we actually, maybe we just need to look at some of their ways in much smaller populations, but we have to deal with the same issues. And so I was just looking at something from Chaco culture and in that time of around 600 to 1200 AD. And I found this really interesting article. And basically, their claim is saying that on the mesas, the people there noticed that water was falling, and it would channel through off the mesas, and then it would go into the arroyos in the area. And so and one of this author was saying that he found evidence of rainwater diversions, these diversion dams, and some areas where they noticed that there was crops in there. So they did some calculations, and it said that if a quarter inch of rain was falling over on the mesas, it would be calculated to produce 540,000 gallons of water, and that would be distributed over 24 acres of farmland, and that's this area right here. So I thought that was a pretty significant finding. That's 1.66 acre feet of water. So that would be enough for one irrigation. Well, actually several irrigations if you wanted to put a pecan orchard there. Not to say that anybody would do that, but in terms of the scale of that, it's a pretty big area. So that's one quarter inch rain event. So that was like a monsoonal event. And if you were to divert those things through conduits, they have diversion dikes, conduits, a distribution basin. So things are happening. It's not new to do any of this diversion, rainwater harvesting. This is really old stuff. So we just need to use some of those things to be more sustainable, because that one of the reasons why, not only the reason why, but I was in China last summer, this time, actually earlier, it was in July, but they had gone through this whole cycle where they pumped water out of the groundwater and they had nothing left, and basically it decimated the area, and they basically made a dust bowl. And this is maybe not well known, but the US dust bowl was pretty famous, but this was in the northwest China, in the Gobi Desert, Taklamakan Desert. This is actually in Gansu province, is further east. But this area was so severe, they actually buried towns from the movement of sand. And I talked to some people there. I'm learning Chinese, so I got to talk to a few people there, and they were saying that the sand would build up over the roofs of their houses, and they would have to dig out, but they couldn't keep up, so they had to just move them out. And there's actually towns that are buried underneath the sand movement because of what they did to the hydrology. And so it's not just aridification, but actually it actually went to desertification, and now they're having to deal with decades of and spending millions of dollars to restore the area. And this is actually one of the restoration areas. So this is actually a dune, and they hand planted every plant. So there's a person there with a little shovel and putting a plant, and they did thousands of hectares of this. And you can see we flew over in the jet plane, and it was just like we flew for like half hour on the jet plane. It was all these little pockets of, so it took an immense amount of work to recover, and they're still not recovered yet from what they did for a few decades of pulling water out of the area, and now they're having to pay for it. So I'm just kind of looking through. We're not heading that direction, but those are some things that other places are dealing with. We have other issues that we're dealing with. Let me just read this. And this is from the IPCC. It says many developed countries are expected to suffer relatively modest physical damage, and some even are expected to realize benefits from future climate change. On the other hand, this is an important part, some developing countries bear less causal responsibility, i.e. some of the areas that are south of the equator, but could suffer significant physical damage from climate change. So that is asymmetry, comparing the ones who result in the changing climate, have the ability to adapt, but the others don't. That's the asymmetry, gives rise to the question of justice and moral responsibility. So that's one of the things I've been talking about to folks, is that is not just that what we do is taking responsibility. So this is also from IPCC. This is right off of their report. So it's the more who might be considered morally responsible for achieving justice for what has been done and what we're going to be doing, and thus a bearer of duties toward others. The middle paragraph says the question of moral responsibility is also key to determine whether anyone owes compensation for the damage caused by emissions. That's emissions, greenhouse gas emissions. And the last paragraph says, what duties do present generations owe future generations, given that current emissions will affect their quality of life? And it's something that I do work with the tribal governments and folks, and this is something that's hits home with them in terms of what we do now. We have to think about what's going to happen in generations from now, the implications of it. It's not just my generation and other people are going to worry about it. It's like if I do this, it's going to impact my kids, and so it's that feeling of moral responsibility looking ahead. It's not like we can't do anything, of course, but it's sort of that if I do at this level, how is it sustainable? Or what should I do it or should I do something else? So it's the duties of our present generation, um, having a moral responsibility to look at what's going on, not just in our backyard, but the global sense of what's going on that also will come back to me, by changing my backyard and my future generations. And then also importantly, I think I've been talking to a lot of folks about this is, the value of our ecosystem. We often value our economics and our health, but I mean, but do we truly value the things that are out there? And it just graphic kind of shows you the things that we care about. We may not care about blue whales here, but we care about pikas. We care about the bun, wild animals that are outside, that are endemic to our area. So I'll read this as if animals, plant species, and ecosystems do have a value in their own right, then the moral impact of climate change cannot be gauged by its effects on human beings alone. So it's something do we value them as well, and do we consider them in our decision making? And often we don't. We just think about our economics parts, and not really think about other things that go on. So the rest I want to talk about some the path forward and looking things. I gave a talk to the MNerd and the Department of Health a month ago, or actually maybe a few weeks ago, on kind of the directions where we're going to go. And this is globally here. I know we'll talk to Mexico. So this is where we generate electricity. So the power that powers my room right here in my office, my computer, the internet servers that go from our trucks to the different areas. Where do we generate our power globally? Right now, the bottom part here, um, um, we burn liquids like oil, and then the blue is nuclear, the black is coal, the darker blue is natural gas, and the green is renewable. So right now we're basically in here. This was generated just recently. This was forecast for the whole year of 2020. So this was a 2019 graph. So we're expanding renewables, which is great, and we're also expanding natural gas a bit. So by 2050, our generation of electricity is going to need to be expanded, and that expansion will need to come from renewables. And so our here's kind of the percents of each of the type of fuel generated to make electricity. Right now, most of it globally is from coal. So in terms of the percent of the net electricity generation, we want to squeeze that down to small to get rid of it. However, natural gas is pretty much is likely going to stay around, although we'd like for it to go, but I think with our current economics, it's likely still going to be around. But renewables, if we can clamp the renewables and kind of crowd out natural gas and coal, so we're going to get most of it. We still need to have reserves, and that's kind of the forecast from the U.S. Energy Information Administration that those are still going to be around. This is the forecast out to 2050, but renewables are going to be our major source of electricity by then. Right now, it's a significant fraction, but it's small compared to coal and natural gas. But they're seeing that it's going to increase. So what about the U.S.? Where's our greenhouse gas emissions? Well, right now it's pretty close in terms of three things. Transportation is the most. The cars we drive, the trucks that are around, and then like our electricity generation, and then the stuff that we buy, the industry, the manufacturing, and then fourth is the residential and commercial electricity, and everything goes in with that. And then the fifth is agriculture, 10%. So if we want to make improvements, we need to address all of those. However, which ones are the most impacts? Looking at, so how do we reduce transportation down? how do we reduce the electricity and industry? So if we can squeeze those down, what are, this is the 2020 publication. So, and it's like it's very similar to the previous year. And so, what are some of our options? So here's some of our kind of our path forward direction. At least for New Mexico, we've got to come up with some local solutions. We can't delay. We need to keep moving on because we know what things are going to look like. Knowing what all those nasty things that I showed in the first 10, 15 slides, we don't want it to get that bad. It's already bad in some places, but we want to keep it and even improve it if we can. So these are some of the pathways, but it's not just New Mexico. We need the country, the rest of the world to do these things, but we got to start somewhere, with new um, ways of generating electricity through photovoltaics, concentrated solar, expanding the wind energy sectors. That's basically increasing that green bar on that graph in the previous slide, is increasing our green bar to get all the way to totally replace coal and natural gas. Expanding residential, commercial, and governmental rooftop solar. It's getting solar everywhere where it needs to. We've got a great resource here. We're not using it as much as we can. In some areas, not at all. And we've got some geothermal resources, and we also need to be able to have that renewable to power a electrification transportation system. Right now, if we have electrical transportation, meaning like electric buses and cars and things, it's being powered by natural gas and coal, and some nuclear. So, however, we need to have it. The renewable is actually powering the electrical part, and so that's going to make that's going to be part of a statewide resilience and adaptation plan, which we're starting to do, but we don't have a plan as a master goal for New Mexico. We're getting there. We've got some things going on. We've got emission reductions, which are great, but we need to be more organized so that we can do these things. There is some plans out there. They're not approved yet, but we're getting there. So, and this is sort of we've some of the politicians have talked about some of these, and sort of, yep, we know what needs to get done. We need to do it. So that's kind of the closing the loop. But these are opportunities. So new jobs for people in these energy sectors, having new things to study, new research areas, kind of refocusing, putting all our energy into these topics. I think it would really boost our economy, and a lot of stuff. We're already doing some of these things, but we're not doing it in earnest and not really using that. And so if we're not, then it's going to cost more money. But if we really put in our effort to do these things, I think that's probably our best effort in the next several decades. And things are not going to come fast. We're dealing with COVID-19. As I sit here in Las Cruces at New Mexico State University, we're facing all kinds of budget cuts, no new programs. So things are kind of, we're stuck in a rut right now where we got this tire spinning. And we need to get out of that. Think outside and solve these issues, because it's not going away. It's just getting worse if we don't do anything. And so our path forward needs to incorporate. So how do we get out of that rut and get back on track to do these things? So that's my whole talk about climate change, the impacts, who are they impacting, and then some of the solutions here. So I don't want to leave on a negative point of view. I think this is a positive point of view, and I think there are lots of opportunities, and I think I'm excited. I mean, I got solar on my house. I was really excited about it, and I get to look at it on my phone. But I had to pay for a lot part of it, and not a lot of people don't have the money to lay down that amount of money and then finance the rest of it. So we need to make things more affordable and more options for folks. And same thing with electrification of vehicles. We don't have enough charging stations. I would love to get an electric vehicle, but I can't. It's not feasible. I don't just drive around Las Cruces. I'm out doing maintenance on stations out all over the place. And I mean, maybe I'm an exception, but if I want to go to Albuquerque or Amarillo, there are places where there's no places to charge. If you go along I-25 or I-10, not so bad. But once you go off on 70 or other roads, only Teslas can probably go out there. But then the cost of Tesla, I could not afford one right now. So there's not an option. We need to think of other things to do while we wait for the industry to kind of build momentum. And and I'm very much I like cutting edge technology, but it's still like, okay, I don't make that much money. I can't buy these things. I'd love to do that, but I can't. So there's that momentum that needs to get kind of still moving along. Other places are good, like if you in Los Angeles, the big cities, it's much easier to do some of these. But New Mexico is going to be one of a later one. I think there's efforts to actually boost it, and it's great. I know I've been keeping track. I have an app that shows where the power stations are, and they're getting better and much more available and cheaper. But it still has got a ways to go before it becomes a normal way of life. And I think that I really look forward to when getting electric car and everything electrification is the norm, and no more internal combustion engines. And even flying, if I'm going to fly and visit my family in the East Coast, it flies with a renewable powered jet. That would be my dream, and seeing how things, and then that technology is transferred to other countries, so I could fly to Beijing in a renewable powered jet and not have to be concerned about my carbon footprint in powering a 16-hour flight with jet fuel going all the way out to the Arctic Circle and coming back. So there's a lot of things I wish were there, but we have to wait and see and be part of the wave. Be a uh, enjoy some of these, and then invest in some of these. Vote the politicians in who are behind this. That's our role right now, and encourage people who have the money, go for it. Get that momentum going. So I'll stop there with the climate change. I want to give one more thing. I mentioned, and Jan mentioned it as well. Let me turn off my. Actually, let me go to the slide. So the thing is, what we're doing is, you can be involved in helping us track climate, and it's through the citizen science program called COCORAS, and it's a abbreviation: Community Collaborative Rain, Hail, and Snow Networks. It's really an exciting group, and so basically the hardware is very simple. So you get these little, it's a plastic rain gauge, and I have one right here in front of me. And you install it in your front of mine's actually in my front yard, because my backyard has a bunch of trees. So I proudly show my rain gauge in my front yard for my neighbors to see. And I just pulled off the map from September 9th, which was a nice precipitation event for Taos County. And there's a few very dedicated and really thankful for the observers, but we need more. We need more folks. And this is one of the maps. Let me just show you the map. I just did a screenshot right before this meeting. And so this is the new map that's on the website, and it's cocoras.org. And so there was more than 10,000 observations in by 4 o'clock this afternoon, and it's colored by all the different precipitation events. So here's that big storm that was going through Houston. If you look at the news, there's all kind of flooding. So there's up to 7 inches of rain fell in the Houston area. We got a few areas. I think somebody mentioned you guys got some sprinkles in Taos. Here's that. You see the blue showing maybe a few tenths of an inch around to a few hundredths. Nova
No, I
Scotia
got
looks like got
400.
some. How much did you get?
400ths
400.
yesterday
Yay.
afternoon. That was the most in Taos County. Everybody
Yeah,
else
that's
was seen to
awesome.
be a trace or a.
Yeah, but this is that's if you were to go on a map, probably look almost just like this. Maybe a few more observations. You can see how many people have contributed today. And so we do other things. We do condition monitoring as well as evapotranspiration. But this if you want to get involved with this, we are glad to have you help in getting engaged, just like one of these right here. And I generate these maps. My computer makes them every day. I don't do it anymore. It's a script that runs in my server, And it's almost the end of the water year. So water years start in October 1st and it goes through September 30th. So it's almost a year's worth of precipitation. And these are not every site, but for those who contribute 80% of the days available in that year, I made a dot on the map and then colored it. So there's actually one station that's gotten over 31 inches of precipitation in New Mexico since October 1st, 2019. I should send them a prize because that's a lot of rainfall. Most areas in Las Cruces and southern New Mexico have only gotten, in the teens, maybe 12 inches, or a few areas that, and you can see where the blue, those are, less than 10 inches. And there's a couple ones that are a little more, in a few areas that have only gotten a couple inches. Most of them are at least gotten 5 inches in that light blue. And so that's the sign for drought. I mean, you can see that, but we need more observations across New Mexico. So what do you need? What can you do? Well, how can you become a part? Well, basically if you want to become a part, it's you've got most of what you need right now. You need to sign up on the website, kokoraz.org, and there's a link on the bottom right of the website to buy one of these gauges. It's like 30 some dollars right now. You just get that in the mail, and then there's some instructions on how to install it. Just like that picture right here, you could put it on a piece of wood or a piece of fence or something that doesn't fall over. And depending on how much snow you get, you want to put it above your highest snow. So if you're more in the higher elevations, you want to put it above the ground just a bit. But you can put it fairly close to the ground. It won't hurt. Once you get your gauge, you can go online. There's some training slides on there. On the upper right, there's a train me button that says online training. Or if there's enough people, I can always do a Zoom just like this, and we can go through on how to do a measurement. Or you can contact Jan, who will be a great trainer to get you online. And then you set up your gauge, and then you start measuring, and just wait for the rain. And most of the days it's nice and zero. Most of the time you don't see anything in this gauge because let me turn off my, well, I can't turn it off until I come out, but it's really easy to actually measure precipitation on this gauge. It's if you're a little hard of seeing, you can see the little black lines, and that's every little black line on here is 1/100 of an inch. I don't know if you can probably can see my screen thing is taken over my background. But that's, if you're really interested in helping out with measuring climate, this is just precipitation. Remember, we do rain, hail, and snow. So the most frequent thing falling down is rain, but this is a time of year when we get the snow. So we usually take off the top funnel and just leave this open and let the snow fall in here. And if you get enough, you can actually measure the amount falling on the ground. And then we occasionally, mainly in the spring or fall, and so mostly in the summer, we get hail. But not a lot of hail falls down, but that is something else that we do track. So if you're interested, check out the website, get in contact with Jan, she'll get you set up, and go for it. I think that's a exciting thing to do, is be part of this. And some of the maps that we use for drought actually uses the data from these gauges across Kokoraz. And so it's not only just for fun, it's actually official climate measurements. As a citizen science, you actually have ability to help build the climate record for New Mexico. How much more can you get empowered if knowing that your data is building the climate record for New Mexico? Your site, actually, your data actually goes to a federal repository, and the National Weather Service, they use the data. They report, especially if it's a really big snow event or a rain event, they'll actually write it up and put it in some of their storm reports. And so, and if you get like a really big event, there's even a way to report that. So if it's like you've got an inch of rain, it's overspilling, and I just got it. It just fell down in the last 10 minutes, some really nasty rain. You can actually report that, and the Weather Service will immediately read it and they'll actually issue a statement. So like in Taos County, the nearest radar is at Albuquerque on the West Mesa, which doesn't really make its way there. It looks at the high elevation. So they really treasure these observations from gauges like this that are much that really provide more information than the weather radar, which those are like $10 million instruments, these weather radars. But these gauges actually can measure the rain better in areas where the radar can't reach. You know, there's mountains blocking the way. You got the Jemez Mountains blocking it, so the beams have to go pretty high up in order to reach Taos County and Rio Arriba County. So they really use these gauges and the measurements every day. It's an everyday measurement for decision making. I use it to make drought maps and other states as well. Like we talk with the state of Colorado, and they have the same network, and it's actually started in Colorado. And so we make maps that are it's all four corner states, and these gauges make up a big part of those maps that we generate in this drought monitor. So it's really important. So I encourage you to, if you have somebody who, if you're not able to do it, maybe you have a neighbor who may be interested, and I could send a brochure, or you can go on my website and I can send you the link, or you can go to the CocoRa's website, cocoraz.org, and say, hey, yeah, I think you would enjoy participating in this, and it really is exciting. So I think that's about all I have to say. I love talking about this stuff. And I'm very passionate about what goes on in the world and my backyard, and trying to get more people to sign up to help out with this. Like Jen said, we've got people all over the place, and she does it. And we got several people in the south part of Taos. We really would enjoy folks everywhere, even if it's just your neighbor. I like my neighbor at 2 houses away. He also has a gauge, and it's funny that some days he actually measures a number different than mine. And so, and it's sort of the variability of precipitation in New Mexico. You can get not quite a factor of 2, but it's 10% difference, maybe more, 20% difference between his house and my house, and he's only a house away. And it's amazing, and we would never know about that unless we actually had measurements. So it's not only scientific curiosity, but these are actually serious measurements, serious instruments to be used, and provide some, in some cases, even flood measurements. If we get like 2 inches falling in one day, that's a big deal for New Mexico. Not a big deal for any other place near the Gulf or the East Coast, but if we get 2 inches or even 3 inches, which I've seen, there's a massive flooding that we can have, and we saw that a couple of years ago in Santa Fe. Took out the arroyo and people's cars, because they had 3 inches of rain in one day, which is an amazing amount of rain. So I'll be happy to answer any questions about anything we talked about, or if you have another topic about climate or climate change, I'd be glad to help out. And if you're on social media, there's my email. But if you're on social media, I run a Twitter account, very active. It's NM Climate. I also run a YouTube channel, NM Climate, as well as Instagram, NM Climate. So anything NM Climate, I've already stake my claim. And so I post pictures of clouds and whatever I find, and post notes of meetings and things like that. So yeah, if you're into that, go for it. I also have a Facebook page too. It's not called NM Climate because that was already taken, but it was the state office of the state climatologist. So I'll pass it back to you, Jan.
Well, I will add that you do have some fantastic Instagram pictures. I've enjoyed those as you've traveled east and west a little bit this year.
Fun.
And your Las Cruces pictures, because I love Las Cruces. I said I get down there once or twice a year. If anybody has any questions, go ahead and unmute yourself and just talk. There's not many of us left. Oh, Peggy, I think your daughter, you should get a rain gauge for your daughter. Get her involved in measuring that.
I love that idea. I want to get one. And my daughter actually joined the conversation, was taking notes with me and stuff too.
Good. Well, tell Jennifer hi.
She wants to make some posters to put up around town.
Cool.
That'd be awesome. Yeah.
Yeah. Yeah. Thank you so much.
Yeah,
Yeah.
it's the reason that I get up every morning is to go out and check the rain gauge. Well, maybe 1 out of every 30 mornings. Let's put it that way. It is very easy to enter because if you have a bookmark, you click on that and the default entry is 0. So most days in New Mexico, especially this year, it has been, you just hit 2 buttons and that's it.
Yeah, and we have a special thing called Zero Heroes. Those are the people who submit a 0 even though there's no rain. So I use the zeros because that tells me that there's no rain, and
Oh,
that's
yeah.
a very important thing for me.
Yep. Yep. So there, let's see, there was Jim, Jim Ludden, who was on earlier. I think he's gotten off now. He has an air quality monitor.
That's great. Yeah, Purple Air
Visible on
is a really nice.
purpleair.com.
Yeah, if you're interested in air quality, I encourage you to get one of those. They're a little bit pricey. It's like a couple $100, but basically you can tie it to your Wi-Fi, and then it goes to a national map, actually a worldwide map, and it shows you the real-time air quality index at your house. You can do it. You can do an indoor one, which is cheaper. I think it's like $160. But there's also an outdoor one you can like post on a fence post, and
Yeah.
it records it all the time.
So that's separate because he's got a weather station he's got on Weather Underground too,
That's great.
which he's got posted there on the chat thing. So anyways, great seeing you again, Dave.
Yeah, it's good seeing you all. Yeah, especially you,
Things
Jan.
aren't much improved since the last time you talked to us, unfortunately.
Yeah, you know,
That great rain year we had, the anomaly last year, we had 15 inches. I had 15 inches, I think, last year.
yeah.
Oh,
Well,
I have
enjoy
Why-
those times.
why is the water year like a fiscal year? October to
Well,
period.
one of the reasons why they have it start in October is a lot of the hydrologically important things start in that time of year. So like our snow. So
Okay.
when we first get a snow, usually it's in the late fall, like this time of year. Actually, we actually had a really early storm, right? Did you guys get any snow?
We did. I got a little at my house. Teresa got, I think, an inch or so.
Yeah, that
snow.
was extraordinary. We usually don't get those that early. That was like one of the earliest ones. I know that a few areas like I think Las Vegas, that was their earliest ever of snow, but some of them were within a few days of that. But we get it starting right around October, and we get still some rain events, but that's the time of year, and then we like to record all the way through the end of September, and it just happens to coincide with the federal fiscal year too.
Yeah, and Mary's up in Denver most of the time, has a house here in Taos, but how much did you get? Was that a record early snow in Denver, Mary? If you unmute.
Actually, it wasn't a record snow or early snow, but it was one of the few that we've had that early.
Well, certainly a record extreme temperature change. You changed like 50 degrees in
Yeah.
24 hours. We were close to that, I think. But
Yeah, I remember seeing some of the Kokoras during that day. There was like 15 inches of snow, like in the San Luis Valley and those hills over there. It's like, wow, that's a lot of snow.
oh, really? Oh, I missed that.
Yeah, it's like, wow. Somebody got is I think Springer. I think they got 5 inches, which
Wow.
that's a lot for that early.
That's true.
My husband he's hunting, he's bow hunting up in the La Jarra Reservoir area by Antonito, Colorado, and he got 3.5 feet in the
Whoa,
mountains there. He was trapped for about 4 or 5 days.
that's
Really?
that's
With
crazy.
snowfall just a couple weeks ago?
Yeah.
3.5 feet?
Uh-huh.
Oh my
Yeah,
God.
he put his walking stick up there to kind of measure the melt each day to see when he could try to get out.
Wow, that
my
is
God.
amazing.
Yep.
Yeah.
Yep.
Yeah, I
Okay.
mean, as climate changes, more evaporation, and it provides more water vapor, and that is one of the kind of the things that we will see is, we can get really big we can get really big snowstorms when we get really warm temperatures. I mean, it's that whole process, the hydrologic process, more evaporation, more available water vapor, and you can get these little events that cool down and you can get some record snows, even though it's a record hot, that whole month, just like 2011, that was above average February. But we had that really big, deep freeze. We were below zero here in Las Cruces, and then it went right back up again to above average. So those are the kind of things that we're tracking is, climate change, the outlooks, things like that, the forecast models. That's the kind of thing that's happening, in the future more than they are now. Is climate change says, well, we're going to have more of these extraordinary events. It may not be more precip, but we're going to still see extreme precipitation events and some record cold, but it'll be followed by a record warm